Hello. Today we will continue solving unexisted problem of Stack Overflow. So let me introduce you the way how we can avoid Stack Overflow at all. Generally, there are several ways of doing it, but all of these ways are actually using the pattern of moving calculations, of moving actual functions called stack from a real system stack to the heap. Yeah, there are such languages as Golang and maybe others which can dynamically increase the amount of thread stack in order to avoid its overflowing. But we are still in Java, and Java it's a very old virtual machine implementation. Of course, it has a lot of advantages, but it can't dynamically increase the stack amount of any thread. So we will use a simple pattern. I call it custom stack. So instead of making a recursive call, we will have some magic instead of it, and we'll return some complex object, and that allows us to move in all the evaluations on a heap. Here are these macroses. We can go deeper, but it's quite a bit hard. Eval CS is actual macro, eval custom stack, and blah 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 blah. But let me show you on examples. First of all, if you remember on previous nail, we had a function which summarized all the natural numbers from 0 up to the given number. And we implemented it in naive way, in tail recursion way, in non-tail recursion way, with trampolines and and a lot of ways. But today we'll implement it via custom stack. CS, it's abbreviation for custom stack macro. We'll call it. It's actually wrapped in custom macro call of function for decremented argument and incremented accumulator. And eval CS is a wrapper, the same pattern as we used for trampolines. Here it's a pattern for evaluating function foo on arguments 10,000 and 0. Yep, it returns immediately. It works the same way as it may be predicted. But also we can use this custom stack on non-tail recursion, on non-tail call function. So function bar is not a tail call case. But we can use custom stack here. Let's try it. Okay, the same value. We can also use a custom stack on mutual calls, which actually trampolines helps us, but we can do not use them, but use custom stack. Let's try. But here we see that it takes a little bit longer time in comparison with a naive stack or in use trampolines. Yes, of course, it's a payment for for the ability. If my custom stack was faster than system one, then maybe a question why we should still use the system stack. So that's the payment. Slightly less productivity. But here I can show you one interesting point about Stack Overflow at all. It's about a so-called evaluation tree. There are different evaluation trees may occur in your evaluation process, but I try to, to show you three interesting ones. First of all, it's only one branch, only one line. It's actually not a tree, it's a evaluation line, and that is actually a sequence, a chain of calls in one direction. It's actually a tail recursion, tail call. It's exactly actually a one branch of evaluation tree, only one line. The second thing is a very wide evaluation tree. We can use Fibonacci, naive implementation of Fibonacci recursive function as an example. It's a very wide recursion tree, and Stack Overflow, it's hard to achieve Stack Overflow in this case, because we achieve time overflow first. we will never finish the function until it reaches the Stack Overflow. That's the case. So in these cases we also do not be afraid of Stack Overflow. But there are some intermediate case. If recursion tree is wide and not deep, but one or maybe two of its branches are actually deep and throws until the Stack Overflow. Yep, that's a special case. It's very interesting if you are trying to visualize the evaluation tree, and one or several branches would be so deep and other branches would be short, but all the tree exactly would be so wide. So that can be shown here. For example, coin change, well-known coin change task. You have some amount of money, you have a list of possible coin values, and you have to calculate how many ways is to collect all the coins to fit the desired sum amount. Yes, we can implement it in a naive way, without calls any custom stacks and so on. Yep. And coin list, let be 1, 5, 10, 25, 50 cents, and change $1 can be changed 292 ways. It's well-known result. If I call the bigger amount of money on the same coin list, it will calculate a lot of time without memorization. So that's why I use the special case. I use a big amount of money, but a very short and limited coins list, which some strange coins of 1 cent and 1,000 cent. But it allows me to emulate that non-linear evaluation tree, but with one branch which is deep and throws Stack Overflow. Let me show you. Yeah, Stack Overflow problem. How custom stack can help us here? We have a memoized way of custom stack, a memoized macro. So we will use it here, only at one place. The base of memoization, and then wrapper function and its arguments. So the same coins list and coin change of 100 cents of coins list 292, and the big amount of coins list, yeah, big value, big number, but it it evaluates immediately. And the same value here, the same example. Well, maybe let me do it this way. 10,000. Yes, it's only 11 ways, but here it creates a Stack Overflow. Again, we can use it on Fibonacci, but here we just use a memoization part of this custom stack. Actually, we do not have to use custom stack here, because we do not fit Stack Overflow with, even without custom stack evaluations. But it also works. And even not so-called primitive recursive function. What do I mean? There are a term, so-called primitive recursive functions, and a lot of